Hi, everyone. Today, we are going to do a lesson called partial fractions. Um, this can be one of the trickier lessons for integration because all the other ones have a very straightforward formula, and you just follow the formula and you got to find out the pieces for the formula. This one, we're doing a little bit more algebra involved in it. So we're just going to take it slow bit by bit, and I am going to try and preemptively answer your questions like I would if I had a class and students were asking these questions. Okay, so example 1 says consider the proper fraction 13 over 35, and it says express the fraction as a sum of two proper fractions. What in the world does that mean? That means I want you to give me two fractions with different denominators that add together to give me 13 over 35. So kind of going back to your algebra days, go ahead and pause the video and try this. All right, welcome back. So normally students, they take about 10 minutes to do this, but normally people come up with answers, a lot of different answers because there are many different answers to this particular questions. So we have 13 over 35, and we want this, and a lot of students come up with something over 5 plus something over 7. And to represent those somethings, I'm going to use A and B. And what I mean, so for example, is some students will say, well, 13 over 35 is equal to -1 over 5 plus 4 over 7. Or they might come up with 13 over 35 is 4 over 5 plus -3 over 7. So they come up with a lot of different options. These are just some examples. So something over 5 plus something over 7. But where does that 5 and 7 come from? A lot of times people just say, well, it was very intuitive or instinctual. I just looked at that 35 and knew it had to be 5 and 7. Um, and when I can normally get students to kind of more express where that 35 come from, they'll say, well, 35 is really just 5 times 7. So if I want a fraction, or if I want two different fractions added together with different denominators, I need to make sure that they multiply to give me 35s. So 5 and 7, which is very true and very much what we want to use. Now, I'm going to show you how I solve this. Just note, I'm going to make this more complicated because that's what we are going to use today. So we have 13 over 5 times 7, and this is equal to something over 5 plus something over 7. Now, I want to know what the A and B can be, or what they are. So what I'm going to do is I am going to, and I knew I wasn't going to leave myself enough room, scoot this over just a little bit, is I'm going to multiply both sides by 5 times 7. So 5 times 7. And I get 13 equals A over 5 times 5 and 7. The 5's cancel out, and so I get 7A. Plus, when I multiply B over 7 times 5 times 7, I get 5B. And so all of a sudden, I have an equation that allows me to figure out, okay, what is A and what is B? So we can just say let's let A equal -1. So if we do that, we get 13 equals 7 times -1 plus 5B. And so to solve this, we have 13. I'm going to add 7 to both sides, so 13 plus 7 gives me 20 divided by 5, which is 4. So B equals 4, which gives us our first example. -1 over 5, so that A was over our 5, and B was 4, so B plus 4 over 7. And we can plug different numbers in. We really like numbers that work out to be whole numbers. We really don't like fractions. So if I just plug in a random number, so we had this equation that 13 equals 7a plus 5b. And we can let a and b be anything, but then we have to solve for the other one. So if a equals 1, we get 13 equals 7 times 1 plus 5b. So 13 minus 7 gives me 6, and then divide by 5, we get 1.2. So our equation would not look very nice. We would have 1 over 5 plus 1.2 divided by 7. We can use that, but it's not a very nice number. I would stick with A's and B's that give me whole numbers, so still more of a guess and check. What we're going to do after this is we'll find actual numbers, or actual equations that fit. So even though in our heads we can find numbers that add together to give me 13 over 35, you guys probably found these just by doing it in your head. This is the math that's going on behind it. Okay, so you're probably asking me, Katie, why are we doing this? Why are we going back to our algebra days? So now let's look at an equation, because we might want to integrate something like this, and we can't integrate a function that looks like this just by looking at it. We have to do some algebra work on it. So let's express x minus 8 over x squared plus 2x as a sum of two proper fractions. Okay, so we have x minus 8 over, I'm going to go ahead and factor this. So notice up here, we had 5 and 7 because we factored the 35. Well, if this was a number, we would factor it. The x's are just placeholders for numbers. So I'm going to go ahead and factor this. There's an x in both of these, so I'm going to factor an x out. And then when I do that, I'm left with x plus 2. Okay. So the first step that I did here was factor the denominator. I'm just going to put denom for short. So I factored the denominator. Now, the next thing that I did up here was once I had these factored, I had a 5 and 7, I said I want something over 5 plus something over 7. We want the same thing here. So we want something over x plus something over x plus 2. Okay? So this is our new setup. So step 2 was I write 2 or more, because we might have more factors, fractions using factors. So we have the factors, and we write the fractions using those fractions. We write the fractions using the factors. Excuse me. Man, that's a tongue tie. Okay, so now we're going to solve. Step 3, solve for A and B. And we're going to do some sub-steps here. So the first thing that I look at that I don't like about this is there's a bunch of fractions in there are fractions. There are variables in the denominators. All right. So let's multiply. Uh-oh. My computer stopped responding. So let's give it a second. There it goes. Okay. Uh-oh. Okay. My note's worrying me that this is going to crash. So I'm going to multiply both sides by x times x plus 2. X times x plus 2. Okay. When I do that, the x's cancel, the x plus 2's cancel. On the left-hand side, I'm left with x minus 8. And on the right-hand side, I'm going to write this out. I'm going to need a lot of room to do this, so I'm going to move this down. My computer is running really slow, which worries me. Okay, so I'm going to come down here and write this. I may run out of space later on. So I have x minus 8 over here because these cancel. But on the top, we really have a times x plus 2. I want to write this out so you guys can see what's going on. Plus b times x plus 2 over x plus 2. The x's cancel, the x plus 2's cancel. So I have x minus 8 equals a times x plus 2 plus b x. So when I'm solving for my a and b, the first thing that I do there it goes, is I multiply both sides by my factors. Okay. I'm going to close this down and reopen it. Let's see if that helps. All right. Everything's still there. Okay, let's zoom back in. Not sure what's going on here. Hold on, guys. I am sorry for the technical difficulties. Okay, so we multiplied both sides by the LCD. And now I'm going to solve. I want to solve for A and B. So I'm going to multiply this through. And so I get x minus 8 equals a x plus 2a plus b x. Now you're probably asking, Katie, how are we going to solve for a? How are we going to solve for b? Well, notice on the left-hand side, we have x minus 8. And so we have some number in front of x minus a number without any x's. So let's set up our right-hand side equation like that. So I'm going to grab everything with an x in it. And so I'm going to rewrite this. X minus 8 equals ax plus bx plus 2a. So I'm going to make it look like that left-hand side. And I have x minus 8 equals x times, I'm going to rewrite this. Sorry, guys. Sorry, computer. I know I'm making you freeze a little bit. So a plus b times x plus 2a. And now I have something in front of my x, which technically I have a 1 here. And so I know that what's in front of my x needs to be what's in front of this x. So what I get is a plus b equals 1. And then everything that doesn't have an x in front of it needs to equal everything that doesn't have an x in front of it. So I get negative, let's do it this way, 2a equals negative 8. So what I did was I got a systems of equations from setting up my equations so that look the same on each side. So this is my system of equation that I need to solve. So part B, set up a system of equations. And so I can solve this first. So 2a equals negative 8. So a equals negative 4. And then my next equation, I have a plus b equals 1, but I know a is negative 4. So negative 4 plus b equals 1. And so b, so I'm going to add 4 to both sides, equals 5. Okay, I ran out of room at the bottom of my page, but we know, we're almost done, guys, with this problem. So we had x minus 8 over x times x plus 2, and we know that is equal to a over x plus b over x plus 2. So we have x minus 8 over x times x plus 2 equals our a is negative 4 over x plus b, which is 5, over x plus 2. So this is how our equations break up. And if I was to integrate this right-hand side, it would be way, way easier than integrating this left-hand side. So last step, C, solve systems of equations. Okay, so I know this probably felt a little bit like magic. So I'm going to zoom out so we can see this most of this whole problem. And let's kind of go through it step by step. So step 1, we factor the denominator. So we have this denominator of x squared plus 2x. We factored it into x times x plus 2. And then we write our fraction using that. So a over x plus b over x plus 2. Then we need to get a systems of equations, so we need to do some algebra magic. We're really solving for a and b. So I'm going to multiply both sides by x times x plus 2. Just our normal solving pattern of what we would normally do. But then we get x minus 8 equals a times x plus 2 plus bx. This is where people get a little lost and they're not quite sure what to do. You're halfway through the problem. You're almost to the answer. And what you want to do is you want to make your left-hand side look like your right-hand side. So you want to group all your x's together. If we had an x squared in there, we'd get all of our x squareds together, all of our x's together, all of our non-x's together. So all of our just constant numbers together. And then we'd group them and we pull out that factor. So in this case, we had ax plus bx. We pulled out the x and we had a plus b. And then last, we had just 2a, and that just kind of stays together. There can be more complicated problems where you might have like 2a plus b plus c, and that's just your regular numbers. And from that, you can say, okay, well, what's in front of the x needs to equal what's in front of the x on both sides. So what's on the left-hand side is a 1. What's on the right-hand side is an a plus b. And then for the non-x's or our constants, we have a -8, and that needs to equal 2a. That gives us our systems of equations to solve. Once we solve that, we can set up our equation. Okay. If you need to, pause the video and rework this. Now, we're going to actually work an example, and we're actually going to integrate this. I did not give myself 2 pages, which is not the smartest thing in the world. I normally do. I suggest if you have the book, maybe go to the end of the section and use the 2 pages there. Or you guys might be writing small enough because you're writing on by hand and not on a computer. What I'm going to do is I'm going to use this page, and if I need overflow, I'm going to come out here. All right, just a heads up, these problems are long, and I'm going to show all the steps versus skipping a lot of the steps on the integration. Okay, let's zoom in. Let's see if I can not aggravate this computer. Okay. So example 3 says evaluate 9x plus 11 divided by x squared plus 2x minus 3. Okay. We cannot use substitution here because if we did, this is the wrong answer. And I'm going to do this in red. I'm going to show you why this does not work. Don't write this down. So a lot of people might say, okay, why don't we do use substitution? U equal x squared plus 2x minus 3 du over dx equals 2x plus 2. So du would be 2 over x plus 1 equals dx. That's a fine assumption because we have an x squared here, we have an x on top. Let's just see how it works. So we have the integral of 9x plus 11 over x squared plus 2x minus 3. Actually, I'm going to go ahead and substitute the u. We've been doing u substitution long enough that I'm just going to say u du over 2 times x plus 1. The problem is, on top here, this is not x times x plus 1. It's 9x plus 11. I can't factor the 9 out to make this look like x plus 1. This whole piece is bound together. You can't say I'm going to just cancel the x's out and then the 1's there. That's an entire factor. Has parentheses around it. It's kind of being eaten by those parentheses, and you can't separate it. It is just there. And same thing up here. I could add parentheses here. And so that 9x plus 1, there's not a number that can be factored out to make it look like x plus 1. So this does not work. This makes me grumpy. So we need to use partial fractions. I'm going to try and erase this all in one whack. Let's see if my computer does not shut down. Delete. Okay, I think it's speeding up. I'm going to say that and it's going to stop working again. Okay, so that means we have to do partial fractions. So let's look at this. I'm just going to take the integral and dx away. I'm just going to ignore that for right now until I get it to something I can integrate. So I have 9x plus 11 over, and I'm going to go ahead and factor this. X plus 3, x minus 1. If you are not very good at factoring, send me an email. I do have some videos of how I explain for people how to factor. A lot of it's guess and check, but I do have a video explaining. Okay, so we factored this. We want this to equal something over x plus 3. So a over x plus 3 plus b over x minus 1. All right, so step 1, take our factors, or I guess we're at step 2, we're going to write our fractions using our factors. So we have 2 fractions using the factors x plus 3 and x minus 1. Next step, I never leave myself enough room on the left-hand side. When I'm writing on a whiteboard, I still don't. So I'm going to multiply by x plus 3, x minus 1 on this side, x plus 3, x minus 1. And I do like writing this step out so you guys can see what's going on. Okay, x plus 3, x minus 1, those cancel. So I have 9x plus 11 equals a times x plus 3, x minus 1. If you guys can skip the step, feel free to go ahead and skip this. I always have some students that if I don't write this step down, at least for a problem or two, they're lost for the whole lesson. So I do write this out. B times x plus 3, x minus 1 over x minus 1. So my x plus 3 cancels with my x plus 3. X minus 1 cancels with my x minus 1. And we are left with 9x plus 11 equals a times x minus 1 plus b times x plus 3. Okay, I'm going to take a break, let you guys catch up because I'm sure you're back at the top. When I am all alone, right, doing these videos, I don't have students to slow me down. So I know sometimes I go a little fast, and I apologize for that. Okay. So now we want to start solving for A and B, and we're going to do that by just go ahead and simplifying these equations as much as we can. We essentially want to get that right-hand side to look like something in front of an x plus a non-x, a constant. So I get 9x plus 11 equals ax minus a, and multiply that in, plus bx plus 3b. That is a B, not an R. Okay, again, I want a number in front of my x plus a non-x. So I'm going to rearrange this right-hand side. 9x plus 11 equals everything with an x in it. I'm going to highlight it in blue. We have this with x's in it. So I have ax plus bx. And then everything that is a non-x or a constant number, we have negative a and 3b. Minus a plus 3b. So I have it in this kind of form, but I want something in front of an x, and I've got 2 x's here, and then just a constant. So I'm going to rewrite this one more time. 9x plus 11 equals a plus b x minus a plus 3. And that's kind of together. I'm just going to put plus there. Okay. So now I can set up my systems of equations. And so I get, let me set blue, the number in front of the x, number in front of the x. So I get a plus b equals 9. And my non-x's, that is a b and, nope, that's a 3b. Sorry, guys. Plus 3b. There we go. So I get negative a plus 3b equals 11. All right, so now we have to solve the systems of equations. This one's a little bit harder than we did before. I'm not sure. This is my system. I'm not sure if you guys remember from algebra that you can add two equations together as long as they're equal. So I'm going to add these two equations together. So I'm going to add them. And what I get is a plus negative a. My a's go away. But b plus 3b gives me 4b equals 9 plus 11 is 20. And so divide both sides by 4. And I get b is equal to 5. Okay, and I can take that and plug that into either equation. So I have b is equal to 5. And then I know that from equation 1 that a plus b is supposed to equal 9. And b is 5, so I get a plus 5 equals 9. So a 9 minus 5, because I really do use my handy dandy calculator a lot. And bring this up. And so, there we go. We had 9 minus 5, which is 4. I do apologize that my brain took that long. Okay, so I have my a and b. So that tells me, therefore, with 3 little dots, I have my a was 4, b was 5. So 4, let's rewrite my equation. So 9x plus 11 over x plus 3, x minus 1 equals 4 over x plus 3 plus 5 over x minus 1. I'm going to double check that I have my a's and b's right. My a was over x plus 3. My b was over x minus 1. Okay. So there's my equation. All right. Well, the initial problem asked us to integrate. It said, yep, I'm running out of page. We want the integral of 9x plus 11 over x plus 3, x minus 1, dx. And that is going to equal the integral of 4 over x plus 3 plus 5 over x minus 1 dx. And we can actually do use substitutions on these and integrate them. So we are going to do that. Notice that I am out of page here. So I'm going to go off to the side. Let's see. I'm just going to go off to the side. This is where you might want an extra page. Some of you might write it small enough to do this. So we have the integral of 4 over x plus 3 plus 5 over x minus 1 dx. And we want to integrate this. So I'm going to break this up into the integral of 4 over x plus 3 dx plus the integral of 5 over x minus 1 dx. And we can do use substitution. If you can integrate this, great, go ahead to the answer. I can look at this and integrate this in my head. A lot of students can. If you cannot, do a use substitution. It's okay. On the test, I will make sure you have enough time so that you can do use substitutions on these. Okay, so I'm going to integrate this one first, and then I'm just going to do the other one in my head. So if u is equal to x plus 3, du over dx is equal to 1. So du equals dx. So we have the integral of 4 over u du plus this one's just going to come down. We're not messing with it yet. Okay, so the integral of this, notice that it's a number over a u. This is just ln. So we have 4 ln of u plus the integral of 5 over x minus 1 dx. My u was x minus 3. So 4 ln of x, plus 3, sorry, plus the integral of 5 over x minus 1 dx. Now, I'm going to do this one in my head. There's no x squared here. There's no number in front of the x. It's just a linear term. We can just integrate this. It's an ln. So without doing a u substitution, we get 4 ln of x plus 3 plus 5 ln of x minus 1 plus c, and we are done. I'm going to put a smiley face at the end of that because that took a long time. Okay, if you are my student, you are probably curious, Katie, what steps can we skip on this? How can we make it shorter? Uh-oh, it froze again. There it goes. So I'm going to come off to the side a little bit further if it'll let me go. And I'm going to show you, come on. Okay, it won't let me. I'm going to scroll down. I'm going to show you how you can do this problem quickly without showing as many steps, and I'm okay with that. Personally, working on a problem this long, I like showing my steps so I can go back and like, okay, what did I miss? What did I do wrong? Okay, so here's a quick version of this. Oh no. So we had that 9x plus 11 over x plus 3, x minus 1 equals a over x plus 3 plus b over x minus 1. A lot of people skip this and go straight into 9x plus 11 equals a times x minus 1 plus b times x plus 3. That is perfectly fine. Everything I'm showing you, you can do on your test if you want to skip that many steps. And then I often see 9x plus 11 equals ax minus a plus bx plus 3b. And then a lot of people skip to that 9 equals a plus b, 11 equals negative a plus 3b. And then they solve this in their calculator. So however you solve this, I often just get a equals, what did a equal? 4, b equals 5. Your calculator can do systems of equations. So I'll show you really quickly. So if you get your system set up, I have to remember how to do this. Sorry, give me a second. So second, and then x to the negative 1 gives you matrix. We're going to edit our matrix. This is going to be a 2 by 3. And so we are going to have 1, 1, 9. So the number in front of the A is 1, the number in front of the B is 1, the number we're solving for is 9. So here we'll have negative 1, 3, and then 11. And you get out of this, so second quit. And then go back into matrix, math, and where is it? RREF, hit enter. Second matrix, A, close parenthesis, and enter. And so our A is 4, our B is 5. And so then what I see oftentimes is the integral of 4 over x plus 3 plus 5 over x minus 1 dx. And then we get 4 ln of x plus 3 plus 5 ln of x minus 1 plus c. Okay, so if you want to skip a lot of steps and you want to shrink it down to 1 page, you can. If you do this in your calculator, you need to tell me matrix and calculator. If you have the TI-36 Pro, it can also do this for you. I don't use it very often. I think one semester I tried to show students and it just kept falling apart. So our next problem we'll go over in the calculator and by hand. I just like by hand. It tends to work a little bit better. Not better, but students tend to understand it more. Okay. So I'm going to stop the video here. This is just kind of a little intro into partial fractions. Our next video will do 3 more examples of different cases of what can happen with your factors. And that'll be the end of partial fractions. If you guys have any questions, I know I went through this really quickly, but if you have any questions, feel free to email me and ask. Rewind the video, rewatch it, especially the calculator part. I know that kind of gets a little tricky, but just let me know. All right, guys. Talk to you later.